So in continuation to the previous class, let us prove another identity of vectors, that is, if f and g are two scalar point functions. So f is a scalar point function, g is a scalar point function, just like phi in our usual notation. So f and g are two scalar point functions, then prove that div f del g equal to f del square g plus del f dot del g. That we have to prove. So before entering into the solution or proof of this identity, we must know about div of some vector point function. So here it is, g is a scalar point function, del g is a vector point function. If you multiply f by a del g, again you will get a vector. Ultimately it is a vector. Bracket part is a vector. Now div of that vector. So we have basic formula, div f bar. If f bar is f1 bar plus f2j bar plus f3k bar, if f bar is like that, then div f bar will be, that is, dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. That is the formula to find divergence of the vector point function. So whenever f bar is f1 bar plus f2j bar plus f3k bar, now div f bar will be equal to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. That is the basic concept which we are going to use in this concept. Now, first of all, see the LHS, div of f del g. First of all, start with del g, where g is a scalar point function. So given that g is a scalar point function, for that scalar point function, if you apply del, that is del g, nothing but grad g. According to gradient of a scalar point function or del g, we have the formula like this: I bar into dou z by dou x plus j bar into dou z by dou y plus k bar into dou z by dou z. I bar into dou z by dou x plus j bar into dou z by dou y plus k bar into dou z by dou z. Whenever g is a scalar point function, we have del g is like that. For that del g, you have to multiply with f. F is also a scalar point function. So that will be f del g. Just applying f. Now that will be f del g is equal to I bar into and just I am applying f into dou z by dou x plus j bar into f into dou z by dou y plus k bar into f into dou z by dou z. Just we are multiplying del g by f. So f del g, that is the bracket part. F del g is equal to I bar into f dou g by dou x, j bar into f dou g by dou y, k bar into f dou g by dou z. That is f del g. For that f del g, we have to apply div. So take that div of f del g. Let us discuss this. Now that f del g is a vector, let it be f bar in that case. Now div f bar, we have that formula, dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, where f1, f2, f3 in that formula are nothing but here f dou g by dou x. This is f1, this is f2 and this is f3. f1 I bar plus f2 j bar plus f3 k bar, that is in that form. Now f1, f2, f3 we have. Applying that formula, what you will get? So dou by dou x of f into dou z by dou x plus dou by dou y of f into dou g by dou y plus dou by dou z of f into dou z by dou z. This is like f1 I bar plus f2 j bar plus f3 k bar. Now dou by dou x of f1, dou by dou y of f2, dou by dou z of f3, using that formula. For div f bar, it is div f bar in that notation. Now coming to this part, f into dou g by dou x. F is a scalar point function, dou g by dou x, that is also scalar. Both are functions. Now here product. So UV formula, you have to apply UV formula. Dou by dou x of f dou g by dou x. If you apply UV formula for that, what you will get? So f into dou by dou x of dou g by dou x. Dou square g by dou x square. F into dou by dou x of that. Plus dou g by dou x as it is. Dou by dou x of f will be dou f by dou x. Applying UV formula for that. Derivative UV formula. In the same way for the second term and third term. Again, f into dou by dou y of dou g by dou y. Dou square g by dou y square. Plus dou g by dou y as it is. Apply dou by dou y to f. So that is dou f by dou y. Plus for the third term also apply the same formula. UV formula. Derivatives. Now f into dou by dou z of dou g by dou z. Dou square g by dou z square. Plus dou g by dou z as it is. Dou by dou z of f. That will be dou f by dou z. Now for this term and this term we are applying the same formula. Derivatives of uv. So u into derivative of v plus v into derivative of u. Usual formula. So here f into dou by dou x of dou g by dou x plus dou g by dou x into dou by dou x of f. Applying the same principle here and here. We are getting these terms. Now in these 6 terms, 1, 2, 3, 4, 5, 6. 6 terms are there. See the first term, third term and fifth term. They are the like terms. First term, third term, fifth term. In all the first, third and fifth, take f common. F common. What remaining? Dou square g by dou x square plus dou square g by dou y square plus dou square g by dou z square. Dou square g by dou x square, dou square g by dou y square, dou square g by dou z square. Taking f common. Plus, now remaining terms. Second term, fourth term, sixth term. What are they? Dou f by dou x. Just writing in order, reverse order. Dou f by dou x into dou g by dou x. Plus, dou f by dou y into dou g by dou y. Plus, dou f by dou z into dou g by dou z. Now here, f as it is. See the bracket part. Dou square by dou x square, dou square by dou y square, dou square by dou z square of g. You can take g outside. That is nothing but del square g. So, after taking g outside, dou square by dou x square plus dou square by dou y square plus dou square by dou z square, nothing but our del square. So, f del square g taken outside, f del square g. Plus, and we know that del f and del g. Here del g already there. Del g nothing but I bar into dou g by dou x, j plus j bar into dou g by dou y plus k bar into dou g by dou z. That is del g. In the similar way, del f will be what? Del f is I bar into dou f by dou x plus j bar into dou f by dou y plus k bar into dou f by dou z. If you find the dot product between them, we will get this step. So this is nothing but from here to here, if you maintain the bracket like this, that is nothing but the dot product of del f and del g. So that is del f dot del g, that bracket part. Because del g is here, in the similar way, del f will be like this. If you find the dot product between del f and del g, we will get this bracket. So that is nothing but our RHS, that only we have to prove. So that is the identity number 3. Okay. So let us continue the next class for the next identity. So thank you very much.